Others fly smooth as silk. Yours shakes like a rickety crate. 3 tips to fix it. From hardware to software, even beginners can master. Troubleshooting jitters follows a path, outside to in, hard to soft. Start with propellers. Look at these edges. Worn sharp here is a normal blade. Worn blades lose balance, causing visual jitters. Another issue. Blades look fine, but after a crash, the wingtips might be warped upward. This also throws off the balance. Here is a simple test. Tilt the frame, spin the prop, and check if the edges show any layering. Like this one, it is quite obvious that the weights are not perfectly even anymore. There is clear layering. This blade here shows no sign of layering. That covers props. Next, let us check motors. They consist of a stator and rotor. If the shaft bends the center rod, it causes friction against the internal magnets. If you want to know how to detect a bent shaft, just take it apart. Remove the screw, disassemble it, swap the position, and reinstall. Just like checking the props, spin it to inspect. This is a healthy motor. A faulty motor's outer rotor will show visible side-to-side wobbling. Spin it. This one is good. If it wobbles, the motor must be replaced, as bent shafts are beyond a player's ability to fix. Motors and props checked, move to screws. Some frames use rigid mounts, attaching motors directly to the chassis. Others, however, use 3D printed parts for mounts. Beginners often fear over-tightening, which leaves these parts loose and screws unsecured. You should tighten them firmly for safety. This causes the motor assembly to shake. After assembly, mount the props. Grab the motors and check for any noticeable movement. Motors covered. Let us discuss camera jitters. The most common cause is loose screws. The camera is held by 2 side screws. Make sure to check them after every single flight, because they often come loose due to vibrations. This is truly the most frequent culprit behind it. Also, look at this rig. The lens is mounted to carbon plates. Even if the lens is secure, the top and bottom plates might press against it. Over time, or due to cutting precision, the camera mount might be stable but loosely integrated into the frame. Check all structural mounts. That is the second cause. Third, some frames use TPU prints for vibration dampening. But TPU parts age over time. TPU pads shrink and harden, causing jitters. When this happens, simply replace the worn TPU pads. After checking the motor and lens, we now start to adjust the PID parameters. If you take our footage, for example, the wavy shaking you see is the P-axis jitter, which we must fix. Before adjusting the P-axis, set up the drone first, turn off FF, and reduce Dmax to half of its initial value. Keep I and FF values as they are. Adjust the D-axis first. To adjust the footage, move the D value within 0.3. Then, adjust it higher or lower, as high D values cause heat and lag. Stabilize the shake first, then slowly lower the D value. After setting D, you should begin to adjust I and FF carefully. Use the same method as before, but with much smaller steps. Start around 0.2, then change by 0.05 gradually. Taking our 5-inch drone, for example, when I lowered it to 0.85, the footage became very smooth and stable. Finally, add FF to the mix. While adjusting FF, pay close attention to the stick feel on the roll and yaw axes. Find a comfort zone. Slowly bring Dmax back until the lag is acceptable. Save your settings and check these 3 steps before flying. Quite a difference, right? To summarize, check motors, frames, then PID. Like and save if needed, and ask questions in the comments below.